but I haven't gotten to that part yet. Okay, and cart 2 is going to have the clay cup. It's a banana plug that's just got a little cup that's stuffed with clay. So when cart 1 bumps into cart 2, it'll stick to it and they'll move on as one. By the way, that's called an inelastic collision when they stick together. Okay, so this cart is in the center of the air track, and cart 1 is to the left of the photo gate. And let's see, you're going to click collect data and wait for it to turn red. I think we're using 2-gate timing again. Yes, 2-gate timing. It's in the OneLab files folder. So you click collect, wait for the button to turn red, then you give this one a push. I'm going to have to keep pushing it. And you don't want to be pushing it when it passes through the photo gate. You want your finger not touching it when it enters. So you push it here, and then you want it moving of its own volition when it goes through that photo gate. I have to cheat because I don't have an air track. And now it's going to give you the speed. It's going to call it speed 1 of cart 1. Then they're going to collide. I thought that might happen. And they're going to pass through the second photo gate. So it's going to give you 2 speed values as each flag passes through, okay? I'm going to recommend that you use the value of the first speed value that it gives you. I mean, you could take an average, but I think that the one that's going to be the most accurate is the one that it reads closest to when the collision happened, which means it should be the first one that passes through, okay? Everybody with me on that? All right. So, for collision 1, and I would like you to print out the collision. Print out what the screen says and turn that in with your lab.
All 4 of them?
All 4 of them. They only need to be only one person in the group. Like, you don't both have to turn that in. But if your results look real weird, I want to be able to look at what you had to see if I can, because there are some where, the first one's pretty easy to analyze, but there are some that, where they hit each other and bounce back. If you aren't paying scrupulous attention to the signs, the SIGNs of the speeds, the velocities, then it looks like momentum isn't conserved. So I will try to catch that before you leave, but it's just helpful to me if I can look and see what you did. Okay, so there's a data table on page 42. And you need the mass of each cart. Now, you guys, you can use that digital scale to get these. They ought to be around 200 grams, you know, plus or minus 5 grams or so, maybe 10 grams. You want the cart, you want the glider plus the banana plug thing, whatever it is, and the flag. All right? So, that'll be M1. Each one of these is, I want to say 50 grams, but of course they're not marked. I think that's what it is. Anyway, you can mass these. So, in collision 1, cart 2 is definitely heavier than cart 1. Okay, so that one should be pretty straightforward. V2 initial is going to be 0. V1 final and V2 final should be the same thing. That's the reading from the second photo gate. And what you want is M1 V1 plus M2 V2 before and then after. vector, but it's all positive in the first one. Okay, collision 2. Now, collision 2, we're going to have both carts in motion. So now, the masses stay the same. So you've got 2 masses on cart 2, no masses on cart 1. And you're going to start them both on the other side of the photo gate so that they pass through the photo gate before they collide. Now, if you will notice in collision 2, it says initial velocity of cart 2, right to left. Make yourself a note. That means its initial velocity is negative, okay? So for collision 2, cart 2 has an initial negative velocity. Now, here's what's going to happen. So this cart 2 and cart 1 hopefully are going to meet in the middle, and then it's hard to say exactly what's going to happen. It depends how fast you've got each cart going, all right? So listen to it. If they collide and they go from right to left, the final velocities are negative.